Artificial Intelligence in Retail by The Wizard of Pause. While putting together this presentation, I became aware of how pervasive AI is in retail. It has been used for a very long time. In effect, every time you use a KPI, you're using a form of artificial intelligence. As you will see, today AI has become quite sophisticated. So how does artificial intelligence, machine learning, neural networks, and deep learning relate? If you do a search on the internet, you'll find there's real confusion on AI, ML, DL, what is what. So here's my definition for this presentation. AI is a broad set of tools, technique, and technologies that allow businesses to build systems that can analyze data, understand patterns, and ultimately take action. To focus your efforts on identifying the right problem is critical. What is uncertain event, thing, value that you want to predict? This needs to be something that is very clear and explicit. If people are going to continue to be treated in the same way, then what use is the model? If existing customers are always going to be offered the same level of discount off their next purchase, then there's no point in building a predictive model to identify repeat shoppers. So what is AI? AI, sometimes called machine intelligence, is encompassing intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans and other animals. Machine learning algorithms are just sets of rules and logic statements that are applied in a certain way to create a predictive model. Neural networks is a computer system designed to work by classifying information in the same way the human brain does. It can be taught to recognize, for example, images and classify them according to elements they contain. Deep learning can apply to almost any area of AI. It is also analogous to the way people learn. We observe that what goes on around us, draw conclusions from our experiences about how the world works. We then apply what we learn to help us deal with new situations that we find ourselves in. The more we experience and learn, the better our ability to make decisions become. Deep learning uses multiple layers to progressively extract higher level features from raw input. Each level learns to transform its input data into a slightly more abstract and composite representation. For example, in an image recognition application, the raw input may be a matrix of pixels. The first representation layer may abstract the pixels and encode the edges. The second layer may compose and encode arrangements of the edges. The third layer may encode a nose or an eye, and the fourth layer may recognize that the image contains a face. Importantly, a deep learning process can learn which features to optimally place in which level on its own. This multi-level abstraction approach has an impact on traceability of personal information, not really discussed here. They all lead to predictive analytics, which takes the output out of AI and uses it to drive business processes. So I've created an interactive virtual unified retail model. So what's the point of this? It's particularly when you're talking about AI. Well, the processes, data, and information identified in this model are key components to building an artificial intelligence system. While working on this artificial intelligence presentation, I started with the business store model from the IVRA model. And in the business store model, it shows all of the various applications and their interactions. And I wanted to identify which of these would benefit from artificial intelligence. As it turns out, virtually everything you see on this slide is impacted or can be impacted by AI. Because it impacts so much in retail, I decided to follow the business lifecycle model identified in the IVRA model, starting with business strategies, business architecture, business processes, business organization, enterprise architecture, or basically the data and information, business intelligence back around to the business strategy. So for a business strategy, we might want to know, monitor, and focus on our best customers. This is because a vast majority of our income comes from our best customers. So our question might be, we want a predictive model to identify our best customers. The first question might be is, what do you mean by best? The response are those who make the biggest financial contribution to our business. So we move around the Agile models to the business architecture area where we identify value streams. In this case, we can focus our AI work on the value streams that are tied to best customer, such as selling an item value stream or returning an item, or the BOPUS value stream, or a direct-to-consumer value stream. So now that we have the business strategy and value streams, let's take a look at the AI business process model itself. Of course, it starts with establishing those goals and objectives. Then it starts talking about inputting data. Now, the first and most important part is the training data. During the model's construction, development data is presented to the machine learning software. The relevant algorithms are run, and a predictive model is produced at the end. Then there's all sorts of data sources. This is where you can discover and profile data for clean, reliable intake and ingestion. There's all sorts of sources of this. For example, text. What people write and say can be analyzed to identify what they're talking about and the sentiments being expressed. Images, covering photos and videos. Location, information about people's location and movements, for example, in a car GPS system or other mobile device. You can get into knowledge network, and this is information about people's connections and who they know. Biometrics, you can start including information about blood pressure and heart rate and stuff connected from Fitbands and smartwatches and so on. And one of the largest sources of data, of course, is the IoT, the Internet of Things. They provide lots of data that can be used to infer people's behavior. IoT and AI, as a significant effort unto itself, delivers a huge volume of security and analysis needs. Check out my Internet of Things video. And then we go to data lakes. This is where all of that disparate data gets stored. It's basically in its natural raw format, either as files or blobs or whatever. The data gets pre-processed. This is where it gets turned into a standardized, compressed, computer-friendly format. See the MDM video for the steps on processing this kind of information. Next is the predictive models themselves. These are generated by the machine learning process using past experience, i.e. huge amounts of large historic data. The pre-processed data for the new cases is fed into the models in order to generate fresh predictions going forward. Those predictions are then fed back into the input data and circled around until they narrow in and focus on a particular model or particular result. Then you start looking at having to apply the decision rules on the data. Prediction by itself is useless. You have to decide how to use it. So there's two pieces to the equation. One is the prediction and the other one is the decisions on what to do. These rules are used in conjunction with the input and the sources from the predictive model to help decide what to do. Sometimes these rules are derived automatically by the machine learning algorithm, but often they include additional rules defined by the human experts and or business users. Then, once you've got this, what do you do with it? Well, that's when you get to apply the rules. So action needs to be taken based on the decisions that have been made. If the decision is that someone is credit worthy, then a credit card needs to be issued. If the decision is that someone should be hired, then they need to be sent an offer letter, given a contract to sign, and so on. And of course, all of this has to be validated for privacy and security before it's actually sent out, especially in today's world. You then get some feedback to go back and make sure and help focus the whole effort. So you see this is another closed loop system, just like the Agile model, to help tailor in and focus in on what you're trying to do. So let us move around to the enterprise architecture area of the model. As we saw earlier with this particular drawing, you can see there's lots of applications in retail, and there's an enormous amount of information available. But only a small fraction of all that data out there actually features in predictive models and is used to make predictions. So once you know what type of data are predictive of how people are going to behave, you can discard most of the other data because you don't need it. Continuing to maintain huge databases of low-value data is not a very efficient use of time and resources. Some of the reasons to exclude the data is it's out of date. It's not representative of your target population. It's not stable. There are legal and ethical reasons for eliminating data. It's not deterministic, or it's inexplicable. You can't explain why it's there at all. So once you've identified your valuable data, you can use the standard models to communicate that insight. AI reaches all aspects of retail, and here are some samples. For example, credit loss. When somebody defaults on a loan, how much of the debt is likely to be written off? Sales and CRM. It could be a sales assistant software designed to automate enhance sales operation processes by identifying and conversing with inert leads, cross-sell or re-engage existing leads. Purchase interval. How long after buying a product can a repeat purchase be expected? Purchase history defines what high-value customers have looked at in the past and compares that information with other data points, such as analytics or website visitors. Customer recommendations, order management and customer engagement capabilities to e-commerce retailers, product recommendations, how much is spent. Spending predicts how much somebody's likely to spend in the next 12 months. Logistics and delivery with robots. Delivery robots can keep food and drinks at the appropriate temperature. Navigation sensors to help navigate a best travel path for delivery. Drone delivery. Payment services. Checkout-free technology, the Amazon Go model, if you will. Fraud detection algorithms to protect the customer's identities. Social media. Social media provides machine language to analyze what articles you've read in the past, type of topics you discuss with your friends, then drives this to content to be promoted to you. Competitor analysis. What did you look at on the competitor's site? Customer insight and predictive data. Product personalization possibilities. Consumer influencers. Who are the influencers around there? This is a whole new world in the internet world, being able to communicate with influencers and then have them tell people about it. Chatbots, search engine optimization, using voice technologies to find things, predictive searches. And of course, robots are huge in the artificial intelligence world, as they can be electronically programmed, they can process data or physical perceptions, they can work autonomously, they can move around and avoid obstacles, they can operate some of its physical parts or a process if it need be. They can sense and change according to the environment. Say somebody drops something in an aisle, they can move around that without, or pick it up and put it back on the shelf. They can show intelligent behaviors very similar to what human beings have. So what are some of the risks associated with AI? Well, it creates a significant challenge for the retailer. It has a potential to impact their reputation. It has a potential to cause a possible loss of revenue by misanalyzing things. Possible regulatory backlash, particularly with the privacy and security world. Potential criminal investigations for somebody hacking in and trying to change things. And if it fails, it diminishes the public trust in your company. Contact me to help with your retail technology strategy. Thank you for listening to this presentation. My name is Richard Halter, and I am the Wizard of Pause. I have a YouTube channel where there are a lot of videos on various aspects of modern retail technology. I also have a self-paced course on Thenific.com called Unified Commerce. And I just released a 3-volume set of version 2 of my book, Arts for Retail, using technology to turn your consumers into customers and make a profit. This book is a multi-thousand-dollar college degree for less than $25 USD, and it's available on Kindle. Thank you.